Hey guys, Mrs. Semeka here. I am here today to teach you about scale models and drawings. And so I have just a few examples for you here of an actual airplane and then a scale model of that airplane. So up here we have this Singapore Airlines plane, and you can tell, that it's pretty giant. I mean, look how tiny these little people are. Okay, and then over here we have a model of that airplane, and as you can see, these people are bigger than the airplane. So this is just a model, and once again, my pen is dragging things around when I don't want it to. Apologize for that. So that's what we're going to be talking about. These two planes here are proportional in size. Okay, if we were to blow up or enlarge this plane, it would represent this plane exactly. It's just a smaller version of it, a scale model. And then a lot of places where you see scale, or another place where you see scale would be maps a lot, because we can't use a map that is as big as the city, so we have to scale it down so that you can see a smaller version of the city. And then there's usually like a little key so you can see, this little first black section represents a tenth of a kilometer in real life. And then another common example of a scale drawing would be a type of blueprint. So anytime you build something, you make a plan for it first. You would draw out a blueprint or some kind of sketch and try to do it to scale. So when when I was little, my dad used to build lots of decks. We would have these like elaborate decks on the back of our house as large as the house. But first, yeah, it was pretty crazy. But anyways, he would first draw a blueprint to map out what he wanted it to look like, and he would, just like this, include all of the measurements, and it would be drawn to scale. Okay, so we could kind of compare it to what size it would be in real life. And so when using scale, you're always going to have a scale factor. So for example, maybe I have a scale factor of 1/8, or 1 to 8. So this means that for every 1 unit on the model, I've lost my pen here. This new slate just drives me crazy. See, it just picks random things up and doesn't put them down. Sorry. So for every 1 unit on the model, I'm just saying unit because it could be centimeters, feet, inches, meters, whatever. That would represent 8 units in real life, or whatever the real life picture is here. Okay, and oh, that's driving me crazy. So another example, maybe they told you this way. So 1 to 56. So maybe for every 1 inch on the blueprint, maybe that represents 56 inches of the real house. Sorry, very sloppy here. Alright, moving on. So I kind of mentioned this earlier, scale models and maps and drawings, they are proportional to the actual building or plane or whatever it is that we're talking about. So if you recall, we talked about proportional before. Proportional is corresponding in size or amount to something, or having a constant ratio to another quantity. So an example would be that 3/4 is the same as 9/12. Okay, we increased this by 3. So maybe this is how big the model is, and this is how big the actual plane is, but it is the same. Okay, so keeping that in mind, you can also use proportions to help you solve these, which is what I will show you here in a minute. So it's basically like I said before, if you have the model plane and you stretched it out to be just as big as the large plane, everything would end up being proportional or the same size. So here are some examples. You'll always get a scale factor. Either it'll say the scale, or on a map it might call it the key. Okay, so we have a model of a C-130 airplane, and it has a scale of 1 to 100. So for every 1 unit on the model, that's 100 units on the real plane. So if the model plane is 1 foot long, how long is the actual plane? So you're always going to use your given scale. Okay, and some of you won't even need to use a proportion. You'll automatically know. All you do is multiply the numbers here, but I'm going to show you it in a proportion so that you can see why it does work out this way. So if a model plane is 1 foot long, so the top, remember, is the units that represent the model or the scale drawing. So 1 foot long, how long is the actual plane? We would put an X down here, and you would solve your proportion. You're just going to get the actual plane would be 100 feet long. Okay, because it gave us foot, we know that it's feet. Okay, if the model's wingspan is 16 inches, how long is the actual wingspan? Again, you use the scale factor, and then the model's wingspan. Okay, the model is on top here, the model measurements, and then how long is the actual wingspan? That would go on the bottom. You'd solve this out. You know, some of you are already going to see. All you're going to have to do is 16 times 100. Which would be 1600. So the actual wingspan would be 1600 inches. Okay, it told us inches right there. Then if the width of each of the model's propellers is 1.62 inches, how wide is an actual propeller? Same thing. You're going to use the scale factor because we're still talking about the same model plane here. The width of each of the model's propellers, so this 1.62 inches goes with the model. Okay, this one unit represents the model, so we put the model units across from the model units. How wide is an actual propeller? That's what we're trying to figure out. Again, you cross multiply here, and you would get that X equals 162 inches. Okay, so I can't even imagine. I don't know if you guys can even imagine my frustration with this stupid thing sometimes. Okay. Yes, that's it. So I just have a few quick more examples here. I hope you're finding this really easy. If not, make sure you're pausing the video and asking me to maybe re-explain some things for you, or rewinding and trying to catch what I'm saying again. So this model of a barn has been constructed using a scale of 1 to 48. Okay, so we need to remember that that is our scale here, 1 to 48. I'm going to go ahead and write that on both because parts A and B still go with number 1. So if the model's barn door is 2 1/4 inches high, how high is the actual barn? Okay, so we've already can see here that the model size is on top. 2 1/4 inches would be 2.25. And then I'm trying to find the actual size. So after I end up cross multiplying this, I get 108, and my label was inches. Okay, and then if the model's silo is 18 inches high, how high is the actual silo? Well, the model size is 18 inches high. Cross multiply, 48 times 18 is 864 inches. Blah. Sorry. You guys probably think I'm crazy. Okay, so there you have it. That's scale factor. It's super, super easy. Scale factor is always given to you as a unit rate, so all you really have to do is remember to cross multiply. I hope you found this helpful. Remember to please, please, please ask questions if something isn't making sense to you. And I hope you learned something from this video, and I will see you next time. Bye.